when we want to move out from waterfall method to agile method, DevOps would act as a steroid. So DevOps is often called agile on steroid. As the name suggests that DevOps is the bridge between development and operation, there is one interesting fact. The birth of DevOps came from a third group. It is neither from Dev nor from Ops, but it came up from the testing group. And this gentleman, Patrick DuBois, actually gave birth to this when he had faced several conflicts between the operation and development. And that is how story of DevOps began. Today, the market is flooded with several tools. Some of them are commercial, and many of them are coming from the open source ecosystem. So as you can see that from here, the development starts by developer committing their, or rather pushing their code to a centralized code management system. It's a code management server. And from there, it triggers the unit testing. What business logic you want to test in terms of unit testing, or even for functional testing or user testing. What are those critical factors which you want to automate in the testing phase, so that you ensure that your code is never broken, there is a clear auditability, and the quality is always achieved. In fact, there is a discipline called test-driven development. Even before someone writes the actual business logic, the maintainer or the project initiator, they first identify what are my critical business logic, and then they develop the test for that and let them fail. Now, with those failure test code, they give it to the developer, and then they say that, hey guys, here is my logic, now it is failing, you develop a code so that it passes. That's called the test-driven development. Apart from that, security checks. It's very integral part of the development process. As and when people are pushing their code to the server, it should immediately check and inform them back that there is a problem or not. Similarly, when you work on particularly open source ecosystem, and even not only open source ecosystem, there are so many codes which are today available in Stack Overflow and in the internet. So how much, when you are copying a logic or code or snippets, are you violating any license agreement with the original author? Those kind of checks may be also possible today. Those kind of tools are available. We can integrate them in the DevOps chain. Once all these are passed, a manual reviewer may press this button before your code is accepted as the source code. And once it is accepted, and then gets stored in a shared folder or a particular place from where the deployment can be started. This part of the process is called continuous integration. Integration means where it is getting integrated. The developer's code is getting integrated with the master branch or the main branch of the source, which should be taken as the single source of truth for your application, and from where your application is actually getting deployed. Continuously integrating developers' code into this system is the CI process. Why it is continuous? Because as in the previous slide we saw that Agile methodology says that you don't wait for the complete logic to become finished or complete application to be finished before you do initiation. You have given a small user story, a sprint, a 2-week sprint, develop this, push it here. They are all developing those small stories given by the business user. A small portion which is completed, they should submit, and that should go through all these checks and continuously get merged with the source code, eliminating the need for a big bang time taking 1 month testing and user testing and things like that. Those dramas are completely eliminated in this process. Once you merge this code, it goes into the operation part, which is how do you deploy now the code, which means that first you have to decide on architecture, then you have to think about how much load it can take, which means that how many app server you need, then you need how many DB server, what DB server, what is the network connectivity, which port they will communicate to each other, what kind of hardening is required. Once it is deployed, do you want to do VS scanning and penetration testing, do a load testing possibly? All this deployment is not done manually by clicks. the experts are still required. The people who used to give this advices, they are still required. They will sit together and then develop a code for this deployment, which is not difficult to write. They are a high-level language, very readable, and using those they will develop this deployment code and then push it to the same Git management system. And then once this merge is happening, that merge will automatically fire this code to deploy it in the production system. There are various methods which you can adopt. One is very traditional, which goes and deploys the code in the running production server. But before that, possibly you have deployed it on one staging server, and on that you have done a final testing. There is a thought where people says that if the infrastructure is very agile, then why do I deploy the code from here to here once again? Because this is the place where I have tested and it worked fine. Can I not destroy this and use this system? Point all the users to this system as the production server. That's one thought. The other thought is that there would be several regions or maybe several app server. Why don't we deploy it in one section of the infrastructure, which means maybe one application server out of 10, and then restrict some of the user to work only from here, while the rest will be still working on the older application server. So the new people, these people, let's say 10 people, they will be working on these as a beta version, while the rest will be still seeing the old code. Those are canary deployment, red blue deployment. There is this developer world. This is the operation world of deployment. And once it goes to the version control system, this is where the continuous integration engine stays, and he fires through one of these Jenkins, GitLab, etc. fires the playbooks, which will go and deploy the code in one of the public cloud. When it comes to the developers IDE, we should make it open because the developer spends a lot of time working on them, how to debug, how to get assistance from the integrated development environment, and that gives them productivity. It's not wise to force them to shift to another tool. Moving on to the source management system, we have taken GitLab as the one. And you see there are many times Git is getting repeated, Git, GitHub, GitLab, Gitbucket, etc. All of them are coming from a technology called Git, conventional Git source management system. There are two things which happens. One is that it maintains multiple versions of the same file, which is, let's say the file is file 1. So there will be file 1, version 1, file 1, version 2. So it becomes very huge and the code management system becomes slow. The developer suffers for that. The second thing is that when developers are away and there is no net connection, etc., and they can't have their code in the local system, so working on this remote system often becomes a problem. Git resolves this issue by creating a continuous snapshot of the files with a commit ID, just like the database redo logs, and anything whatever you are making changes, as long as you have committed those changes, you can go back to a particular commit ID. Therefore, there is no need for maintaining multiple copies of the same code. Today, the Azure DevOps, after Microsoft have acquired GitHub, they have renamed Team Foundation Server as Azure DevOps, and it is purely work based on the Git technology, and GitHub follows all the principles whatever is there. There is a spelling mistake. It is GitLab. Now GitLab is also quite good. One of the major benefits what we find is in the Azure DevOps, it also integrates the project management part, Agile project development part, starting from creating a sprint to creating the code. In GitLab, we have to integrate Jira or some other software to get that thing done. This is a price product completely. This is an open source product with which you can get at least 80% of the feature or 90% of feature, which is good for starting any DevOps journey. And then there are different types of licenses which are available as a subscription basis. Alternate to Git is a centralized SCM, which we touched upon in the beginning. But today I think the Git is more and more becoming the de facto standard for SCM. Now, both Azure DevOps and GitLab is not only a source management system, it gives many features which are listed in the tools, integrates them and tell them that once you are in my platform, you don't have to go and get these tools from the market. But often it happens that the software development is such a wide discipline and security is such a wide discipline for that matter, that whatever is bundled here is not sufficient. You often have to reach out to specialized tool like that. Now, moving up to this CI integration part, both Azure DevOps and GitLab gives you the integrated engine, eliminating the need of any of this. So in case this doesn't serve your purpose, you can fall back to Jenkins. So they can coexist. Now, once the codes are merged, as we saw in our previous slide, you would like to build or rather compile and release the executable version for this. So based on what kind of application you are developing, you will use that kind of plugin. For .NET, you may in the Microsoft world you will use this one. For Android, you will use the Gradle, and for Java, you will use the Maven. Often, along with this, you would also like to pack the runtime and then make a runnable instance of this entire application inside a Docker container. And this particular technology actually reduces the task of this particular block, which is configuration management and VM provisioning, which is mainly based on the current practices of spinning up a VM, configure them, harden them, and then install the application and all the stuff. There are several testing mechanisms which are available, SonarQube and Ops Works, etc. But enterprise security team, the governance team, would like to focus on this one, which is kind of a de facto standard of this as the authentic source of security checking. Then we have the unit testing ecosystem. For Python, we have the PyTest, which we have used in our demo. Then we have the JUnit, which is for Java unit testing, JUnit here. And then you can go further and say that, no, I want to do the actual simulation, user simulation testing. Selenium is the most preferred tool. So there's a drop-down menu, you have to select one, then place an order, and on placing the order, it will go there and pop up a order confirmation window. That cannot be tested using unit testing or functional testing coding. You have to actually click there. Those are the times when you deploy Selenium. And it's also interesting fact that this kind of tool, which is Selenium and user testing automation tools, are the precursor for today's so-called bots. We go to this portion. This is an important aspect for us because not all application can be Dockerized as of today. You still need VM and you still need non-cloud infrastructure or storage provisioning. How do you do all those? These are the tools which can help. SaltStack and Terraform, these three are very new. PowerShell from Windows is also a part of this. These old tools are agent-based, requires a huge infrastructure before even you can start it. For this tool to work on each of these target node, you have to deploy agents. Strength of this tool that it works very well with legacy system like Windows and etc. Ansible, which has been recently acquired by IBM. Previously it was acquired by Red Hat, and then Red Hat was acquired by IBM. So it's a IBM Red Hat product today. This works agentless. You can start from your laptop, but the other major strength in this is that one can go ahead and develop their modules, and every day the open source community, someone or other is developing one. And here is the link which you guys can go and see that I had my contribution there developing one of the cloud router related module. Infrastructure layer, which covers all types of clouds. You need a central log repository. We have worked on one ELK, which is a combination of Elasticsearch, which is a log storage, log Stash, which is kind of a collection agent for log, and Kibana, which is a dashboard for giving the log visibility. Now it is demo time. In the demo, what we want to show is application where there is a inventory. And inventory we have laptops, model, and the current stock. So initially there would be 10 stock, let's say. And then there is an order form. As and when you place the order, it has to follow these two simple business logic that the stock must be present before this form can accept the order. That is a test which the maintainer would initially write as a test-driven application development. And also that when the order is placed, it should go and deduct the inventory and show it in the stock in the order that your order is booked. These also need to be. Apart from that, the maintainer also has set certain code hygiene guidelines, and they are normally a standardized stuff in the world of let's say Python, Java, etc. So Python provides certain standard which is called the pip standard, that how lengthy one line can be. There would be also kind of warning that you are using a backdated code which is going to be phased out very soon. So then obviously the security check in the Python world. In the demo we have used Python, and we have used a software called Bandit, which would do a lot of the security checks as per the standard. So initially, somebody senior in your software development team, after collecting the requirement from the business, creates a software project. Here is the login screen, and let me log in with my login ID. Okay, and you can see that I have all my personal project list which I am working on, and then from here he can go and see the other projects as well, just giving a brief about how it works. And this is my project. I have already pre-created it so that we save some time. This is the test. And I would like to show you that I have started these two business logic which we have discussed. Initially, we have populated the inventory with some number of stocks. Here, Surface Pro, current stock I have given 3. Then we initiate a purchase. We place a purchase order. So we said that okay, let me do some purchase here, and then once I do the purchase, I come back and check the stock inventory and see that it has been reduced by 1 because I placed one quantity order and it is now 2. Along with that, I might have created a basic skeleton which if you initiate a project like this in Python, these files are auto-generated. And once that is done, here in this particular file, the various stages I have defined as unit testing. The test which I have written, that's the unit test, but then how do I fire? I am to show it from here. Then I also want to do the code style check we discussed. We also said that the code security check. These 3 should perform when it is not a master branch. When developers are working, these 3 things will work. And when it is on the master branch, then the deploy will work. Okay, and for each of the stage, what are the commands what it will run? We have to define it here. For example, for running the test, this command is okay. Okay, and for running a .NET test, or for example, running a Java test, what command is there? That the developer normally would know, and he will give this command here. Code style check, I use this software, and it's one single line command which will do this code style checking. We said Bandit is our software for running the security check. Now deploy is a very long process. Whole code, if you have to write down, it will become very unreadable. That is where Ansible comes into play, and then one single line of Ansible which calls a particular code and will show you that code is written separately by the infrastructure team. Once the project is created, I come here and then give the access to my developers. Here I am the maintainer, And this guy, DevOps user 1 and DevOps user 2, they are the reporter, which means they can see the code. They cannot change in this particular project, but they can copy their project in their own place and then work on them. So I have on the project, if I have to assign, let's say Nataraj, so I just can assign Nataraj as a guest or as any of one of them. I can also say that how long he will be working, and then after that automatically his access to the code will be expanded. And that's it. This guy will get a notification that if he has been assigned access here. Apart from that, I can also open an issue. From here, we can create a new issue and assign to the guy, which is assigned to the DevOps user 2, let's say. When he is assigning there, he can also give a milestone which we can actually track. So okay, now submit issue. This issue goes to the developer. So I have assigned access. I have also given in the assigned issue to him that he should work on this particular issue. And then log in as user 2. We see that there are actually two projects for him. One is the actual application. Another is the place where he had again created a skeleton and similarly opened an issue from here and then given it to the infra team for developing a deployment code. Okay, so this is one parallel track which is going on. So essentially he has opened two projects. One is for the infra, another is for the actual application. Now let me go back to the developer who the issue has been assigned, and let's see what he is observing. So here is the developer. He is logging in as a DevOps user 2. Here is a project which has been assigned to him and he is reported on that. And here is the issue and to-dos. Here is that he has been assigned to do a business logic development. That's the issue. And he can update, comment, and the discussion goes on like that. So the first thing what he would do is he will fork it. Fork is nothing but a copy the project in his own project space. Forking is in progress. It has been successfully forked. Enable one small thing here. Go to CI/CD. And he has to go here and then just click on this one. Enable shared runner. He has a runner available and he just enabled it. That is one step which he has to remember. Then he goes back to his project and you can see this is the master branch, but he would like to work on his own branch. Okay, so he creates a new branch here and he says this branch name is user2 branch. User2 branch. Create from master. So he has created a branch which is now shown as user2 amongst very other. You can see this is a master and user2 branch has been created by him. At this stage, we would like to give a brief overview of how this Git forking and branching works. So you consider this is the Git server and this is the developer's laptop. For our demo, we are not using this function. Developer is not working offline. He is directly working on the web development environment. Therefore, everything is happening on the server. So we'll skip this part. Here we have the maintainer which we had shown in our demo. Here is the developer, and developer wanted to copy the project, and after this forking, he automatically gets this copy of this master branch. In fact, whatever branches are there, all the branch will come here in the maintainer or in this side of this project. All of them will come here to the developer. Then developer normally don't change all of them. Any change he can do locally, but when you want to give it back to the maintainer, it will be refused. That's why he is advised to create a feature branch. In this case, the feature is develop the business logic. So he creates the feature branch, works development activities are done here. Then he pushes those to here. That push is called a merge request. He sent a merge request to him. And after receiving the merge request, the maintainer reviews the testing result, etc. And then he is free to merge it here. Now for local purpose, this local operation is called cloning. From his fork, he will do the cloning, then do all the work in his laptop by creating several branches, which he can create either from the master branch and then push it back here to feature branch. He can subsequently create more branches, either inheriting from here or directly inheriting from the master. Some of them he can push, some of them he may not push, keeping it as locally. That is how a combination of forking, branching can give you possibilities of having a different version of the software running in your laptop itself or in the server itself. Some of them you want to push it back and contribute back to the maintainer. Some of them you may keep it for your own to develop a new type of software. Okay, now we want to again go back to our original. Developer sitting from his own project space will go inside the project and start writing the code. For saving time, again, we have already written the code. We'll go to the section, and this particular line is ensuring that if order quantity is either less than or equal to current stock, only then you accept the order. Otherwise it will directly go and then throw a message to the user. The second part is that once the order is placed, it should reduce that many number from the current stock. So current stock minus the order quantity. But let's say by mistake he gives a plus. He's writing a wrong logic. So we'll modify. This is the correct logic, this one, and I am blocking the correct logic. So once order is placed, it will increase the stock quantity instead of decreasing it here. Commit changes. As a result, the pipeline has fired. You see, this has started running, and these are the three different phases. This is unit test, this is the coding style check, and this is the security check. So let's see what is happening in unit testing. It's setting up the initial environment, and then it shows that it has failed. So maintainer have asked that you have to assert the current stock after the order is placed is 2, but he has actually increased from 3 to 4. It should be 3 to 2, but it has increased to 3 to 4, and that is why this assertion has failed and the test have failed. So even if you try to push these changes, the maintainer will not accept it. He again goes back and he changes it. The logic is wrong, so I open the correct logic and block this wrong logic. So the code is corrected, and he says corrected the business logic, commit the changes. Again it will get fired here. It has triggered the pipeline, and again it is doing the unit testing. So you see, this time the job has succeeded. Therefore, if you go to the place, you see the phase 1 is completed. It is now going and checking the coding style. Coding style check is done, and it has given certain suggestions. Missing module, doc string, unable to import, a lot of suggestion it has given. It should give a kind of a score here. So this coding is very bad. It has given negative marks here. I have purposefully bypassed this test and said that even if it fails coding style, you pass this job. And it's maintainer's responsibility to see that what level of discipline you want to bring into while the guy is coding. So now this is passed. He has gone to the third stage, which is security, which has also passed by the time I finished my talk. And it has scanned many areas, and then it has after total line he has scanned this to 280 and have not found any issue. Now once this has passed, I want to send this to as a merge request. If you recollect, we are going to this place. I have completed my work here and sending the merge request back to the maintainer, and I say that it is from my user to branch. It should go to the original user's master branch. That is how it is. Then he gives you option to compare what are the changes he has made. This is more useful for the maintainer to check, and then he submit the merge request. Go to maintainer. I have a merge request pending here. There is a merge request which is coming from user 2. You can clearly see that the pipeline has passed. You see all the stages have passed, and he is now clearly understanding that whatever test cases I have given, they have passed, therefore I can merge. So this is where all automation you want to include. For example, the code compliance check, I said the license check, or functional testing check, or you may even say that before this code is merged, I want to actually deploy it on a staging server, run it, then only I'll merge. You can decide what all workflow you want to do. As soon as it does the merging, it will trigger the deployment, how the deployment has been created. As we said that he had also created another skeleton project which is named as Ansible Cloud, and within the Ansible Cloud, the infrastructure team have pushed in a similar way. They have placed their own request. This particular file, this is how it is deployed. So he is actually creating two number of network. One is for the application net, one is for the database network. He's giving the IP range here. He is creating a router to connect network. These are the security rules. You can read it from here clearly. For the application, he is asking for 8080 port. For the database, he is asking for the database port. Apart from that, he is also asking for a SSH port. Then he creates those VM, and he takes it from a pre-hardened image. Then he goes on and then creates the application configuration. What kind of packages are required in the application? What are the packages required in the database server? Like here you require MySQL server, here you require Python application framework called Django, which is equivalent to .NET in the Python world. It goes on, configures the servers, the database is created. So we are coming into this part of the workflow. Development has done their coding part and it is now ready to be merged. Infrastructure has also pushed their code. It is now time to trigger provision in one of the cloud. Now user 2, it is his cloud account, his initial setup. His initial setup is nothing but certain physical network with the blue, green and orange. Now going back to the merge request which I have received is coming from the user 2, and I am clicking on the merge button. Let me click on the merge button, and the moment I say merge has triggered this creation of infrastructure. We can see that this is the initial setup which is going on. So this is now, you can see he has started creating the network. You see the network has appeared. Here is the application network, here is the database network. And it has connected this database and application network with the physical network. It goes on. It is now creating the security rules. Then it is launching the VM. One VM has appeared here. State is built. CPU, 1 GB RAM, 20 GB disk space. It has become active now. Second VM launched. It is in build stage. This is now active. This script will now pass to the next stage. They are called playbook. Moving on. Now the script has completed the task at the cloud. He will now log in inside the VM. Gone inside the VM, trying to install the packages. And meanwhile, we can see what is the application server's IP. We can see that the application server's public IP is this one, 125. You can keep a copy of this and put it here and see whether our application has come. Not yet come. Application is not come here. This is where it is creating the databases. The table inside the database. And then it is finally able to successfully create the databases. It has gone to the automated testing part. It is doing one more round of testing. The earlier test which was done was using the local database. Okay, here it is actually connecting, application server is connecting to the database server, and the same business logic test is getting run once again. The test is passed. Now it is starting the application and it says the job succeeded. So if the job is succeeded, we should be able to go to that particular page which I had opened some time back. Well, I was trying with port 80. It has to be 8080. Yeah. So that is here. Our application is now live. We can add inventory, which is laptop model. Give it as pin. Add it, and then you go there in the front page. You see the, after refreshing, the stocks will be available. You can place a order. HP, you want to place order as 10 number orders. Currently stock is 90. Give a order and it is 10 is available. Now suppose I want to give order here, which is let's say the laptop is Surface. I want to order it as 12. It should show me error. 12 numbers of Surface laptop are not available in stock. Try different model or reduce quantity below 10. So the logics are working. So essentially, developer wrote the code and the page became available to my to the live server, including the infrastructure creation. The page came alive. That's what is the whole stuff. And then in between, whatever your process wants, you can plug in those processes in the pipeline and run. If he is not satisfied with the code, he can give a inline comment here that what he wants, what kind of change he wants here. The other feature which I also wanted to show you, that you can see a contribution statistics for 3 users in this project and who is contributing how much, you can see from here. This is another very good feature which kind of measures developers' contribution to the project. Thank you for watching.